Okay, we're back, and we are going to now shift into a discussion of theories and hypotheses. So, what is a theory? So, I think you can probably recognize the theory that's depicted in the picture here on this slide, theory of evolution. Really great example of a theory. I wish we had more really great examples of theories in psychology, but we don't have a lot of great, elaborate, well-supported theories, unfortunately. So we're going to borrow evolutionary theory. All right. My little clicking device is just not working correctly. Okay, that's fine. I'll work around you. All right. So first off, a theory needs to be general enough and comprehensive enough to really explain the phenomenon that it is designed to explain. So it needs to have enough detail, enough expansive coverage of content so that it's explaining enough things, and it needs to be general enough that it's open to additional information that may come in the future. So when we talk about a theory, it's simultaneously general enough, non-specific enough that it'll actually cover the information that might come in the future, but then it's also comprehensive enough to account for the information that has happened so far. So the goal of a theory is to explain the existing evidence, the evidence that's been provided so far. So for example, in evolutionary theory, there are a number of different things that evolutionary theory is able to explain. Independently, researchers, for example, discovered that there were layers of rocks and that different kinds of organisms existed in different layers of rocks, and that in general, the things that they were finding in the different layers were more complex towards the surface and less complex as you got down deeper. So that was kind of an interesting thing to find. You know, by digging, you find these fossils and you see how they look, and you're like, this is interesting. All right. Homologous structures refers to the fact that across lots of different species, you'll find structures that look very similar. So, for example, this illustration is highlighting how the shoulder joint looks very similar across lots of very dissimilar creatures. So that kind of implies that maybe they shared an earlier ancestor or something in evolutionary theory. But at the time when people were finding these homologous structures in very different looking creatures, they didn't necessarily know what to make of that. Like maybe this is the solution that one always comes up to with if one is creating on purpose creatures that have, a joint like that. So they were, trying to explain why would we be seeing these similarities. And then you see on the left bottom vestigial structures, and the example that they're showing you is the appendix. In the human, we have an appendix, even though it's not really beneficial to us, although they're starting to see some evidence that maybe it houses a bunch of bacteria that helps to process our food. But it really has a lot of downsides for us, right? It can get inflamed and it can actually kill people. So these kinds of vestigial structures make people question, like, why would we see these vestigial structures in creatures that don't need these anymore? In psychology, we oftentimes talk about vestigial behaviors, like babies display reflexes that are not only not beneficial to them, they aren't beneficial to humans anymore, but they actually might be reducing survival in certain ways. Like there's a startle reflex in a newborn where if their head starts to drop back, their whole body will become rigid. They throw their arms out. They throw their head back. They become really hard to hold. This can't be a benefit. Like, why do babies do that? And the explanation is that it's probably a vestigial reflex that maybe some point in our past was beneficial, but it is no longer. The thing that's important is to look at, like, if we can take all of these different kinds of sources of information, the fossil record, the homologous structures, the vestigial structures, the vestigial behaviors, if we could put all this together and explain it in one big theory, that theory would be really useful, right? And that's what evolutionary theory has done for us. It has taken all of these disparate pieces of information and provided an overarching, comprehensive theory that can account for all the different things that have been discovered so far. So it needs to be general enough. Like, for example, when psychologists started mentioning, well, what about these behaviors that we see? About 30 years ago, psychologists started kind of arguing that there are behaviors that we display today that are probably evidence of what used to be beneficial behaviors in, our far ancestral history. So psychologists started to make this argument that certain behaviors or cognitions that we display today might be evidence of earlier contexts and, demands and things like that. Evolutionary theory is general enough that it can say, well, I guess this theory could incorporate behaviors as well, not just structures and fossils and things, but also behaviors could be incorporated. In fact, cognitions, thoughts could be incorporated under this theory. So it's general enough to account for different kinds of evidence that may appear in the future, and also comprehensive enough to account for the bulk of the evidence that exists so far. The other thing about a good theory is that it will provide a roadmap of what we should expect in the future. And that's really super important, because if we're going to be testing this theory to see if it's accurate and does a good job of explaining reality, we have to develop testable hypotheses and really explore the value of the theory that way. So it has to have these predictions for the future. When I was a little kid, I remember them talking about it in school, that scientists predicted that one day humans will no longer have pinky toes, that they were no longer useful, and so they would become vestigial and they would go away. And all I remember as a little kid was thinking, but I like my pinky toe, I don't want it to go. But that was, evolutionary theorists trying to make predictions about what might come in the future, what changes we might expect given the pressures that we have and so on. So it needs to be general enough to be flexible and comprehensive enough to be, able to incorporate all the information. The big thing that I want to leave you with on the topic of theory before we move on and talk about, valid and not valid theories and stuff, is that you should not think of a theory as a hunch or a guess, not a theory like Sherlock Holmes would generate. I have a theory of who the killer might be. Of course, I'd like to argue that Sherlock Holmes wasn't usually guessing or having a hunch either. He usually was, basing his theory on the evidence that he'd encountered so far and stuff like that. So maybe he's not even a great example of an everyday person kind of using the word theory to mean, I have a guess. I have a guess is a much different thing from a scientific theory. A scientific theory is designed specifically to account for all the existing evidence that we have to date and to make predictions about the kinds of evidence that we should encounter as we continue to search, if the theory is actually accurate, right? So if the theory of evolution is correct, that, the environmental pressures on us is what has shaped our bodies, that we should be able to make a prediction that, under certain kind of circumstances, our bodies might change in response to those kinds of circumstances. And someday in 1,000 years, we might be able to look back and see whether the prediction was right or not, right? So it's not a guess. It's not just a hunch. It's an attempt to explain the data and the evidence that it has accumulated so far. So I thought I'd share with you a psychological theory as an example. So self-determination theory. This happens to be one of my favorite theories to do research on, because it's nice and concrete. And I also like it because it has sort of that positive psychology spin to it, where we're sort of assuming good things about people. So in self-determination theory, the premise is that humans have three basic needs: competence, autonomy, and relatedness. And my little slide shows you what those things mean. They mean what you think they mean. So this theory was created in 1985 to account for the kinds of data that had been collected up to that point, especially from humanists, from people who were looking at people who had depression or avoided depression, or had anxiety or avoided anxiety, and sort of differences in their styles and whether they felt like their needs were being met or not. And so self-determination theory came along to say, it seems like when people's basic needs are met, they are much more resilient. And when their basic needs for competence, autonomy, and relatedness are not being met, then they're going to have poorer outcomes. So this theory kind of looked at what had happened so far in psychology and explained maybe the patterns we were seeing, and then made predictions about circumstances that could lead to psychological dysfunction, dissatisfaction, stuff like that. So I'm going to use that theory as a model as we go through. I'm going to alternate between evolution and self-determination theory as my examples. All right, so that's the definition of theory. So what is a hypothesis? It is a specific testable prediction. Key word there really is testable, and it's a prediction, kind of like we talked about in the last chapter, that if you're going to be doing science, you need to make your prediction first and then see if the data supports it, right? Systematic empiricism. So a specific testable prediction. And now in this context, we're talking about deriving it from a theory, right? So here we have the theory of evolution. We have the hypothesis that, the morphology is going to be affected by the niche that's being occupied. And Darwin had this sort of insight while he was visiting the Galapagos Islands. And he noticed that there were all these different kinds of finches all on these just little islands, and they had vastly different beaks. Apparently, the original normal style for finch is to have a beak that's designed for eating seeds. But on the island, he saw finches that were eating buds or fruit, and they had different looking beaks compared to their progenitors, right? The ones that ate leaves had different beaks, or grubs, and, tool users had different beaks than the ones who ate insects. And so you see these different kinds of beaks on what had started out all one species of bird. And he came to the conclusion that on these islands, that the niche can oftentimes get overused, right? Exploited. And so the birds who had naturally beaks that allowed them to maybe start eating leaves instead did better and had more offspring, and passed that characteristic down to their offspring of having those beaks that were better for leaves. So with natural selection, the idea is that, pressuring your niche can cause certain characteristics to be favored. And by favored, he always meant, additional reproduction, greater access to getting your genes into the future and passing along the traits that you have. So let's apply that to self-determination theory. Now I've zoomed in a little bit on a bigger model that some researchers provided, but basically what they were suggesting in this hypothesis that they used for their study was that the satisfaction of the self-determination needs, autonomy, competence, and relatedness, that having those things satisfied would be associated with better mental health, and they listed some examples of what they're talking about, and better physical health. They listed some examples of what they were talking about. So they make this prediction, this testable prediction. So you could imagine that if you could measure a person's level, how much their autonomy is being met, how much their competence is being met, how much their relatedness is being met. If we could measure those, then we should be able to then measure these markers of mental health, for example, and see whether it is in fact the case that people who are having their self-determination theory needs met have lower levels of, these negative mental health outcomes, higher levels of the positive outcomes, and lower levels of the negative health-related behaviors or outcomes, and higher levels of the positive outcomes. So we have these very specific, very testable hypotheses. Now, we talked before in chapter 1 about things that might be mysteries versus things that might be problems that could be solved. This could be a mystery unless we could figure out a way to measure how much a person's needs are being satisfied, right? And luckily, psychologists have figured out tests and things that will allow us to actually assess the level of satisfaction of their autonomy need, or the level of satisfaction of their competence need, and so on. And then, of course, we have ways of measuring all of the mental health and physical health outcomes, right? So those are easy to measure. So we have a very specific testable prediction that satisfaction of these needs will be associated with these outcomes. And in the study that I pulled that from, they actually tested those things and like that. So I wanted to not just focus on that study in my report. I wanted to kind of look at evidence that maybe self-determination theory is a viable theory for accounting for the relationship between intrinsic needs and then outcomes. So we've got this overall, self-determination theory up in the right-hand corner here. Need fulfillment is associated with positive outcomes is the basic theory, right? So I thought I'd share with you what we do when we're deciding whether the theory is a good explanation for outcomes or not, right? So some evidence that this theory is supported. I just pulled a few examples from the literature. Fulfillment of self-determination theory needs is associated with less depression among nursing home patients. I'm giving you the citation or reference right there. Hypothesis confirmed. The perception of need fulfillment by your partner is associated with less depression. So in this study, they were looking at if the partner was helping to satisfy the individual's self-determination theory needs. And if they perceived that was happening, then they had less depression. And then my final example, the lack of need fulfillment was associated with suicidal ideation. So this study was sort of like an inversion of the typical framing, right? So instead of looking for evidence that fulfillment is associated with good outcomes, these researchers said, well, so the opposite would need to be true, right? Lack of fulfillment should be associated with negative outcomes. And they did find that. So different ways of sort of approaching the same question. They definitely use different methods. They use different subjects. We have nursing home patients. We have people in a romantic partnership. I don't remember who the participants were in the suicidal ideation, but I think it was college students. So we have like different subjects. We have, different outcomes that were being measured, and they're all coming to the same basic conclusion that, having your needs for autonomy, mastery, and relatedness all seem to be tied to having better outcomes. So we might say, seems like a viable theory. It's looking pretty good. But I thought I'd look at some evidence that maybe self-determination theory is not explaining everything. We're going to still be testing the same idea that fulfillment of the needs should lead to positive outcomes. But what we've got is some evidence that maybe it's not a full explanation at the least. For example, we have satisfaction of need for competence was associated with negative affect in children and adolescents. So we have a different subject sample here. This is the first group that is, not in adulthood. And we have those who feel like their need for competence is being fulfilled actually having more negative emotions than those who don't have that need being fulfilled as well. So that's kind of an interesting quirk, right? Now we have autonomy was associated with more symptoms of major depressives. So people who were diagnosed with major depression and who had higher scores in the need for autonomy had more symptoms than people who were lower in the need for autonomy. So interesting. Autonomy was associated with more negative affect in people with unipolar depression. So this one is looking at people, not necessarily more, a wider variety of symptoms of depression, but people who are having more negative emotion as part of their depression diagnosis. So autonomy in particular looks like it might not necessarily always be an ideal or desirable need to be fulfilled, right? If you're trying to avoid the negative outcomes. So I gave you 3 studies that were supporting self-determination theory. I gave you 3 studies that seem to refute at least parts of it. So what do we do with that? Well, one of the things we would do with that as scientists is say, are there substantive differences between the studies that supported and the studies that refuted? I'll give you a little foreshadowing that, the way that they talked about autonomy in these 2 studies on this slide was not in terms of whether that need was being met as much as whether you were high on the need, like you need a lot of autonomy, which is sort of a different angle on the subject, right? So when we're analyzing literature, we need to look at like the overarching relationships between the studies and whether they're all really talking about the same thing, and whether are these 3 more damaging to the theory then those other three were supportive. Like, you got to kind of weigh the evidence. I'll tell you though, I had a really hard time finding evidence that refuted the self-determination theory. I had a really hard time finding these three articles and a really easy time finding the other three. So I'm going to say that more evidence is supporting self-determination theory as a positive thing than evidence that's supporting that it's a negative thing. So now I thought I'd throw in an example of something that's sort of a hot topic for us humans these days. And so I didn't make a statement on this when I put a question. Is it a viable theory? And that is the issue of global warming. So, and of course, climate change, or however you want to call it. This is a really relevant topic for us in scientific principles, because one of the things we're going to talk about this in another chapter, but one of the big sort of rules of science is that we're never really sure that we have found the final evidence, and then we all should stop talking about it. We never should feel like that in science. We always need to be looking, well, to falsify theories. So before I define what falsification is, I thought I'd share with you ways to think about any theory, including something like the theory of climate change or global warming. Now, just to bring you up to speed in case you've been not paying attention to global warming for the past 30 years. So back in the 1980s, a model was created. Climate models were created by different labs around the world, and they entered in the existing data from 1900 was the starting point, because that's really when we had sort of standardized thermometers around the world. And it was all surface temperature at the time too, by the way. We didn't have any kind of other sources back then. And so they plugged the existing data in, starting with the 1900 data, and then they saw it was kind of going up to the right. And you can see that in that jaggedy line there on the left part of this panel. It's the jaggedy lines are the actual temperatures. So those are known numbers. And the green line that's sort of running through it is the smoothing out, giving us the average. So you can see that things were up. Some summers were hotter and some were colder, and like you could see that things were up and down. But you see that smooth line of green that sort of is the average across that time. Okay, then we get off to the right side of the panel where different models have made predictions. And so we see, if we had even higher emissions, where more countries are coming online with more cars and things and factories and things and nobody does anything to control anything, what would we call that purple line on the top? Then we have the red line that's sort of more in the middle, and it's saying, okay, now if we sort of maintain where we are now and other countries come online at the same level that we all kind of are doing already, this is the line we would expect. And then the blue line at the bottom is if we were to take action globally to reduce emissions and things like that, we might see the blue line. So those are the models that were generated back in, I think it was 1985 or something like that. Okay. So the theory is no matter what, the global temperatures will continue to rise. Okay. So I pulled some little graphics because it's kind of easier for us to look at graphics. And this one is from 2013, I think, is when they created this little graphic. But what they're showing here is that we are not seeing the predicted temperatures for the year 2012 that the models had predicted. That by 2012, we were supposed to be higher than we were in 2012. So that's considered evidence against the model. Now this line, or this chart, is again depicting for us that temperature has not risen as fast as projected. So if we look at line A, which is the green line that's sort of jaggedy, it's making its prediction based on 1988 levels of emissions. And you can tell this graphic's older because see how the dotted line starts at 2008. So it's not including like the 2012 data. So this is like a 2008 model, and they're saying it's not rising as fast as the models all suggested, right? If you look at lines B and C, those were, if we were to do nothing, that's where they predicted we would be by now. And you can see that it was lower than that. If you look at the line D, that's the IPCC prediction and much higher than the actual temperatures had been. The National Climate Center has E through F, so they had different models, and E is way back there on the red. So that's where you're seeing that dashed line, E to F. That's the National Climate Center. They're closer. Our National Climate Center is a little closer to what the temperatures actually said. And then G through H is the line that a guy named McKittrick drew. He used to work for NOAA, the National Oceanic and Atmospheric Administration, and he got fired because some of his emails got hacked and released, and he was questioning the IPCC's models and stuff, and so he got fired. But he was arguing that things would be lower, and actually he it's kind of an average between the National Climate Center and McKittrick's prediction that seems to be more accurate. So people are saying, well, the models don't appear to be accurately predicting. Land and ocean temperatures. I just pulled this one because this one's a new one. And what you see is that the land average, which is the red lines, are going up, whereas the ocean averages are not going up as fast. So some people have looked at that data as evidence for global warming, that instead the ocean just lags behind. Others have looked at it as evidence that the ocean isn't rising as fast as land, so that kind of implies that the ocean can be sort of our swamp cooler and cool everything down and like that. So the reason why I wanted to kind of go through all this, obviously you guys, this is not a global warming class or climate change class. I wanted to just show you that when there's a theory and predictions, especially when it's based on models, right? So if you have models where you've plugged data in and you're making predictions about what's going to happen in the future, that's basically a hypothesis, right? You've made a prediction and now we have to wait for the data to come in so we can determine whether the hypothesis was supported or refuted. When we look at the data that has come in since the model was created, it is not necessarily following at the level that at least some of the models had projected. So we have to say the models need to be altered to take into account these new data. And that does it now throw the entire theory into question? Not necessarily, right? The theory is making the projection that temperatures are rising. The hypotheses are the models that are trying to concretely, testably predict how much those temperatures are going to go up. So the hypotheses might be being refuted or partially refuted or being supported. That doesn't necessarily mean that the theory overall is incorrect. So we have to just be really careful when we think about data and whether it means throw everything out, the hypothesis, the theory, everything's wrong. Or like I was saying in my previous lecture, maybe the study wasn't conducted correctly or things like that. So just always keep in mind that first off, the science is not ever settled until all the data is in, and the data really hardly ever is all in. So things are active questions, and questioning things makes you a good scientist. It doesn't make you a person who should be shunned by the other scientists. That's basically the idea. All right. So the final thing I wanted to talk about, and then I'm going to let the playlist show you a video, is the falsifiability criterion. So we're finally to the title of today's chapter. So the falsifiability criterion. Here's what we mean by that. A hypothesis can only be recognized as scientific if it considers the possibility of being incorrect. So I'm going to give you one example from psychology. I don't know, is it really from psychology? It's from Freud. We already established he's not a psychologist. We're going to use Freud for a second. And I didn't really mention this when I was kind of saying why he's not a great example of a psychologist, but let me introduce this concept. He offered explanations, theories, grand theories to explain personality development and psychological disorders and how they develop and things like that. Grand theories. He didn't really collect any kind of controlled data. I mentioned that. But really the big problem with that is that he never considered the possibility of being wrong. He never tried to phrase his questions in a way that he could be shown whether he was right or wrong. He just assumed he was right. And that's not true science, right? In true science, you need to set up a question that you need to make a prediction in your hypothesis that can show you support or failure, right? That's the goal. Now, this video I want you to watch next is going to explain why we need to be seeking out evidence that we might be wrong. So I'm going to stop here, and then you're going to flow into the Karl Popper explanation for falsification.